Hello, today we are going to be solving quadratics by completing the square. So far we know how to solve by factoring and graphing, but sometimes those methods just don't work very nicely when your answers are not exact or rational numbers. So we are going to be expanding upon what we did yesterday, which was finding the C value to make something a perfect square trinomial. We can use that to actually solve quadratic equations. So looking at number 1 here, we're going to solve this by completing the square. The first step when solving by completing the square is to move the constant over. So your quadratic needs to be in the form ax squared plus bx equals c. Now this is different than factoring. Factoring, we tried to get it equal to 0, but for this one we want to try and get it equal to c. So we move the constant over to the other side. So let's take a look at what that looks like in this example. We are going to move that 60 over to the other side. We're going to get x squared minus 4x equals 60. And then step number 2 is we are going to complete the square to make a perfect square trinomial. So to make a perfect square trinomial. So in order to do that, that's what we did yesterday. We're going to take b divided by 2 and we're going to square that. And what we're going to do is we are going to add that to both sides. So in your equation here, what we're going to do is we're going to write a plus and then we're going to leave a space on both sides. So we move the 60 over, we leave a space on both sides because we need to figure out what goes in that space to make the left-hand side a perfect square trinomial. So we're going to take whatever our b value is and we're going to divide that by 2 and we're going to square it. And so when we simplify that, that's negative 2 squared, and that's going to become a 4. So we are actually going to be adding 4 to the left side of the equation. Now, because this is an equation, we have to keep this balanced. We can't just do things to one side and not the other. So we're going to go ahead and add 4 to the left side, but we're also going to add 4 to the right side, again, keeping this balanced. So we have now completed the square and we have a perfect square trinomial. So that leads us to step 3. We are going to factor and we're going to simplify. So on the left-hand side, we can see that x squared minus 4x plus 4 is going to factor. If you remember your x method, what multiplies to get a positive 4 and adds to get a negative 4, it's going to be negative 2 and 2. So your factored form is going to be x minus 2 squared because it happens twice. Now, here's a tip. When you did b divided by 2, whatever number you got there, that's always going to be what your factor is going to be for this one. And then on the right-hand side, the 60 plus 4 is going to simplify to be 64. And so then after we factored and simplified, step 4 is going to be to solve by square rooting. And so this is something that you've done in the past now. So this, hopefully now it looks like a form that you've seen before. We're going to go ahead and square root both sides. We're going to get x minus 2 equals plus or minus. The square root of 64 is 8. So we're going to move the 2 to the other side. We get 2 plus n minus 8. And so if we do 2 plus 8, we get one answer to be 10. If we do 2 minus 8, we get our other answer to be x equals negative 6. So those are our two solutions, and we did that by completing the square. Let's go ahead and try example 2 using the same method. So step 1 is to move the constant over. So this 30 needs to move to the other side. We're going to get r squared plus 6r equals negative 20. And as we move that over, we're going to leave ourselves that space on both sides so that we can do step 2, which is complete the square. We're going to be doing b divided by 2 and squaring it. And so when we simplify that, that's going to become 3. And 3 squared is going to become a 9. Step 3 is going to be to factor and simplify. So the left-hand side factors to r plus 3, quantity squared. The right-hand side, negative 20 plus 9, simplifies to be negative 11. Now this is in a form where we can solve by square rooting. So we're going to square root both sides. We get r plus 3 equals plus or minus the square root of negative 11. And here's where we say, uh-oh, we have that square root of that negative sign there. So this one here is going to end up being no solution. So no square rooting negatives. If that happens, you say no real solution. Okay, so what I would like you to do then is to take a look at number 3. Go ahead and pause the video and then try that example yourself. Okay, so let's go ahead and try this now together. We're going to move the constant, so get it to be ax squared plus bx equals c. So we're adding the 40. You get n squared plus 8n. We're going to leave ourselves a blank because step 2 is going to be to complete the square. So when we do b divided by 2 and we square that, that is going to end up being 4 squared or 16 that we added to both sides. Step 3 is going to be to factor and simplify. So we're going to get n plus 4 squared equals 56. And then step number 4 is to solve by square rooting. So we're going to go ahead and square root both sides. We get n plus 4 equals plus or minus square root of 56. We can take 56 and we can break it down. And so we get, I'm going to bump over here, n plus 4 equals plus or minus 2. There's a pair of 2's we bring out, and a 4 or a 7 and a 2 are left behind. When we multiply them, we get 14. We're going to go ahead and subtract 4 from both sides. We get n equals negative 4 plus or minus 2 root 14. Now we have one rational part and one irrational part, so we cannot combine them. This would be our final answer. Okay, so let's go ahead and try numbers 4 and 5 together. These ones are slightly different than the ones before because now you'll notice that you have a coefficient here. So we're going to start the same way. We're going to move the constant over. And so we have done that. So we're going to get it into the ax squared plus bxc. But now we're going to have to do something a little bit different. We're going to complete the square the same way we did yesterday. So now when we had a coefficient out in front that was not 1, we had to factor that out. So I'm going to have the 8 out in front, and I'm going to divide everything on the left-hand side by that GCF of 8. So 16 over 8 becomes 2x. And here's where I'm going to leave that spot then for completing this square. And on the right-hand side, I'm also going to leave that spot for completing the square. So I'm going to go ahead and actually do my b divided by 2 and square it. Notice my b value changed because I factored out the GCF. This is going to end up being a negative 1 squared. So negative 1 squared is a positive 1, and so that's what we are adding on the left-hand side inside the parentheses. But here's where we have to be very careful because we think we're adding 1 here, but we have factored out a GCF of 8. So we are really adding 1 times 8 on the left-hand side. So on the right-hand side, we need to show that we are not just adding 1, but we have that GCF out in front. So we're going to do the GCF of 8 first times the C value that we got. So to recap here, anytime you factor out a GCF, that's your A value, you have to multiply your A value times the C value that you got when completing the square. So that would help us keep our equation balanced. On the left-hand side, that then is going to simplify to 8, and the trinomial x squared minus 2x plus 1 is going to factor to x minus 1 squared. On the right-hand side, I'm going to do 8 times 1, which is 8, and 16 plus 8 is going to end up being 24. We're going to continue to solve then by square rooting, so we have to divide by 8 prior to square rooting to get the squared part by itself. Then we can go ahead and square root both sides. We get x minus 1 equals positive and negative square root of 3. We're going to add 1 to both sides, and we're going to get x equals 1 plus and minus 3. This would be our final answer. So let's check out another one where you have that a value out in front. So number 5 here, we're going to go ahead and subtract 5 to the other side. We get 4x squared minus 8x equals 5. We notice, again, we have an a value here, so we are going to go ahead and factor out that a value. We get x squared minus 2x. We are going to leave a spot for our completing the square. And on the right-hand side, we're going to also leave a spot for completing the square. We do b divided by 2 squared. That becomes negative 1 squared, which happens to be a positive 1. On the right-hand side, we have to remember, hey, we factored out that a value. So when I go to add things on the other side, I have to multiply my completing the square by my a value. And so on the left-hand side, we're now going to simplify. That becomes x minus 1 squared with the GCF of 4 out in front. The right-hand side, I'm going to do 5 plus, and then 4 times 1 is 4. So that becomes 9. And now I'm going to go ahead and solve this. So I'm going to divide by 4. I get x minus 1 squared equals 9/4. I'm going to square root both sides. I get x minus 1 equals plus or minus. The square root of 9 is 3. The square root of 4 is 2. Then I'm going to add 1 to both sides. So it becomes 1 plus and minus 3/2. And so I'm actually going to do 1 plus 3/2 and 1 minus 3/2 to find my two solutions. So 1 plus 3/2 is 5/2. 1 minus 3/2 is negative 1/2. These would be my two solutions for this one. So now what I'm going to ask you to do is I'm going to ask you to pause, and I'm going to ask you to try one that asks you to factor out that a value. Okay, so pause and try it. Okay, now that you've tried it, we're going to go ahead and solve this together by moving the 3 over. Then we're going to go ahead and divide the GCF out. And as we divide that GCF out, we're going to leave this space on the left-hand side for our C value. Now, when you did this one, you should have gotten this weird fraction here, because when you do b divided by 2 and square it, it does not become a very nice number. It is actually going to be 9/4. And so on the right-hand side, remember, we can't just add 9/4 to that side. We still have that 2 to consider as well. So a times your c, a times your c for that. We're going to go ahead and factor the left-hand side. Now, when we did b divided by 2, that is the value that's going to go inside of your factored form. On the right-hand side, we can simplify this. This is going to end up being 9/2. So if you wanted to imagine getting common denominators, this is really saying negative 6/2 plus 9/2. So this is going to end up being 3/2. Now we can go ahead and solve this by square rooting. So we're going to go ahead and divide both sides by 2. We get x minus 3/2 equals, if you can imagine, this is kind of like saying multiplying by 1/2, so that becomes 3. We square root both sides. We get x minus 3/2 equals plus or minus the square root of 3 over the square root of 4, which is 2. And we move the 3/2 over to the other side. So we get a final answer of 3/2 plus and minus square root of 3 over 2. Thank you very much. I hope this helps, and I hope you have a great day.